that is said and done, this is really the start of the limiting reagent problem. We have the grams of each reagent converted to moles, so we're ready to go. As I'm sure you remember, stoichiometrically equivalent amounts of any two compounds completely react with nothing left over. We know that's really not possible in nature. How do you mix a trillion atoms with exactly a trillion other atoms with nothing left over? It's just not possible. So there's always a limiting reagent and an excess reagent. We need to figure out exactly how much of each reactant it takes to make the reaction go to completion. This means that the reaction goes until one of the reactants is all used up. We do this by figuring how much of each reactant is stoichiometrically equivalent to the other by using the ratio of coefficients in the reaction equation. So, just use the amount given of each reactant, we've converted it to moles now, so we have it in moles, and calculate the stoichiometric equivalent amount of the other reactant. Now, here's the good news. It turns out to be just another kind of conversion problem, and you work it just like you were converting feet to inches. Only the conversion factor that we'll use will be the stoichiometric relationship of the coefficients in the reaction equation. All right. All we need to do is look at the relationship of the coefficients and use that as your conversion factor. And what is the relationship of these coefficients? We have 3 silver nitrates, and we have 1 aluminum chloride. The ratio here turns out to be 3 to 1, and that is 3 moles. AgNO3 is stoichiometrically equivalent to 1 mole of aluminum chloride. And there is our conversion factor, 3 moles of silver nitrate to 1 mole of aluminum chloride. Now we're going to work this just like any other conversion factor problem. We'll do this one first, 0.0248 moles of silver nitrate. Write down what you know. That's what the problem gave us. That's what we know. Multiply it by the conversion factor. From here, 3 moles of AgNO3 to 1 mole of AlCl3. The silver nitrate goes on the bottom. 3 moles. AgNO3 is stoichiometrically equivalent to 1 mole of aluminum chloride. Moles of AgNO3 cancels, and we end up with 0.0248 divided by 3, and that is going to be something like 0.00828 moles. And moles of what? What's left over there? Moles of aluminum chloride. Okay, 0.0248 moles of silver nitrate is stoichiometrically equivalent to 0.00828 moles of aluminum chloride. Good. Now let's do the same thing with the aluminum chloride. Write down what you know. 0.0580 moles of aluminum chloride. And we're going to multiply that by a conversion factor with aluminum chloride on the bottom. What's the relationship between aluminum chloride and silver nitrate? 1 to 3. Same thing as we had before, only inverted. 1 mole of AlCl3 is stoichiometrically equivalent to 3 moles of silver nitrate. And moles of aluminum chloride cancels. And 0.0580 times 3 turns out to be 0.1791 moles of silver nitrate. Now, what does that tell us? Let's look at them one at a time, and we'll start with the silver nitrate, the top equation. If you start with 0.0248 moles of silver nitrate, you need 0.00828 moles of aluminum chloride to take that reaction to completion. That's going to use up whatever limiting reagent there is, whichever one it turns out to be. From the problem, we know that we have 0.0580 moles of aluminum chloride to start with. If it only takes 0.0828 moles of aluminum chloride to completely react with the silver nitrate, there has to be some left. That means that aluminum chloride is the excess reagent, so the silver nitrate has to be the limiting reagent. Now look at the second equation. From the problem, we know that we have 0.0248 moles of silver nitrate to start with. If it takes 0.1791 moles of silver nitrate to completely react with the aluminum chloride, and we only have 0.0248 moles of silver nitrate, then we'll have to run out of silver nitrate before the reaction gets to completion. This, too, means that the silver nitrate will be the limiting reagent. So, now we know what the limiting reagent is. That's the number that we use to calculate the amount of product that we're going to end up with. If your limiting reagent is going to run out and stop the reaction, at that point, that's the amount of product you're going to end up with. So we use the limiting reagent amount to calculate what the problem actually asks for, the amount of silver chloride produced. So once you figure out